So hello and welcome to Elevate classes. In this lecture, I will be explaining some basics of network theory. Now, what is network theory? Network theory is a method to solve electronic circuits. Okay, it is a method to solve electronic circuits. That means finding out voltage, finding out current in a particular circuit, in a particular element through a resistor, through a capacitor, through an inductor, through a diode, one end of the transistor, something like that. Okay, whether you want to find out voltage or current, what you need is network theory. Now usually many students have a फोबिया ऑफ सॉल्विंग इलेक्ट्रॉनिक सर्किट्स. कई फिजिक्स के स्टूडेंट्स को काफ़ी दिक्कत आती है इलेक्ट्रॉनिक्स के सर्किट सॉल्व करने में, और उसका कारण ये है, द रीजन इज that they are weak in network theory. So that is why this first lecture on electronics will be, I'll very concisely try and explain a few techniques, a few important points of network theory which will help you to solve different problems. कुछ इंपॉर्टेंट पहलू, कुछ इंपॉर्टेंट तरीके जिससे आप इलेक्ट्रॉनिक्स के सर्किट्स को सॉल्व कर पाओ. तो आज का लेक्चर बड़ा बेसिक होगा नेचर में, पर जो भी हम आज पढ़ेंगे इसी का इस्तेमाल हम आगे करेंगे, चाहे ट्रांजिस्टर का सर्किट हो, डायोड का सर्किट हो या ऑप एम्प का सर्किट हो. So no matter what kind of a circuit we have further, today will be the base. So that's why this lecture is some basics of network theory. This is what we will use throughout analog electronics. Okay, so let me start with something that is fairly basic and I think all of you know, that is Ohm's law. Okay, what is Ohm's law? Ohm's law is very simple and very basic. We know that it gives you the relationship between voltage and current. We know that they are directly proportional and the proportionality constant is something is called as the resistance. Now this Ohm's law is only valid for linear elements. ये जो Ohm's law होता है ये सिर्फ और सिर्फ linear elements के लिए valid होता है. What are linear elements? All conductors are basically linear elements and the most important linear element in electronics is a resistance. Okay, so basically you can say for our purposes for network theory that resistance is a linear element, valid for linear elements only, valid for linear elements only. Okay, now why am I starting with Ohm's law is, suppose you have a resistor, suppose I have a resistor like this. Okay, this is a resistor R and I am given that the current is flowing in this direction. This is already given in, this is some part of an electronic circuit. Okay, this is one branch of a circuit. Now I want to place a multimeter across this resistance. मुझे इस resistance के across का voltage find out करना है, तो मैं एक मल्टीमीटर कनेक्ट करूंगा, वोल्ट मीटर कनेक्ट करूंगा, एक यहाँ, एक लीड यहाँ, एक लीड यहाँ. ओके, आई प्लेस अ वोल्ट मीटर अक्रॉस दीज टू एंड्स, आई प्लेस अ वोल्ट मीटर अक्रॉस दीज टू एंड्स. नाउ वॉट एवर वोल्टेज आई गेट, this voltage will have a polarity. If you have used a multimeter in your lab, you know that voltages as well, voltages have polarities as well, right? So where do I take positive, where do I take negative? The convention is, see, when we solve these circuits we do not have a multimeter, we are not in a lab. The pen and paper method is, there is a convention for this. In the direction of current, assume this is positive, this is negative. Similarly, if I were to have the current in the other direction, that means I again take a resistor and now the current is flowing this way. Now what this convention tells me is, this will be considered as the positive end, this will be considered as the negative end, and this is the voltage across. And what is the voltage given by? Voltage is given by Ohm's law. Very fairly basic, fairly simple. V is equal to IR. Now, before we move on to the main techniques of solving circuits, there is one more important thing that you need to know. एक और चीज है जो आपको जानने की जरूरत है. That is, when two or more elements are connected in series or when are they connected in parallel. अब आप बोलोगे ये तो बहुत बेसिक हो गया, दिस इज फेयरली बेसिक की हमने स्कूल में पढ़ा था रेजिस्टेंसेस सीरीज में या पैरेलल में होते हैं, या हमने 11th-12th में शायद कैपेसिटर्स के चैप्टर में पढ़ा था कि कैपेसिटर्स का सीरीज कनेक्शन पैरेलल कनेक्शन होता है. दैट इज ट्रू, व्हाट यू स्टडीड इज राइट, बट नाउ यू नीड टू नो, immediately you should be able to identify whether two or more elements are in series or they are in parallel. Okay, so when do we say two or more connect, so when do we call a connection as a series connection? A series connection. Okay, so whenever two or more elements, if there are two or more elements, and remember, whenever I use the word elements in electronics, elements is any electrical device. A resistor is an element, okay, not a solid state device. Essentially a resistor is an element, a diode is an element, capacitor, inductor, transistor, you name it, that is an element. So whenever two or more elements have the same current flowing through them, so when do you what is the main characteristic of a series circuit? Series connection का main characteristic क्या होगा? Same current flows through them. Same current flows through the element. Same current flows through the elements. Whether they are 2, 3, 4, 5, we don't care, but the same current will flow through the element. Let's take an example. Suppose I have a resistor like this. Okay, I have a resistor. Let's call this resistor R1. And then another resistor, I want to connect another resistance, that is R2. And one more resistance, that is R3. Okay, and there is a voltage source connected over here. Let's call this Vs, the source voltage. So this is R1, this is R2, this is R3. Okay, now see, this voltage source is going to produce a current, right? This voltage source will produce a current. Let's say the current is I. The same current flows through R1. यही करंट R2 में से फ्लो होगा, यही करंट R3 में से भी फ्लो होगा. So when the same current flows through all these elements, then these elements are said to be connected in series. This is a series connection. Now this is fairly basic. Why am I mentioning this? I am mentioning this for a reason, and the reason is that in a series connection, the voltage gets divided. This is a very important point. This will help you to calculate a few quantities. Voltage gets divided. What do we mean by the voltage gets divided? What we mean is, see, the entire voltage Vs, some part of this will drop across R1. That means, suppose I have, see, this is the direction of current. So this is plus, this is minus, this is V1. Then this is plus, this is minus, this is V2. This is plus, this is minus, this is V3. Okay. All these voltage drops, this voltage will drop in the proportion to the resistance. And what is the formula? There is a direct formula. This is also called as the voltage divider rule. And the voltage divider rule tells you, suppose I want to find out the voltage across one resistance, R1. Take that resistance R1 divided by all the resistances in the circuit, sum of all the resistances, R1 plus R2 plus R3, and multiply this by the total voltage or the source voltage. This is called the voltage divider rule. This is very, very important. This will save you a lot of time if you know this rule. So in a series connection, what is important is, we know, basically perhaps due to your previous classes, you already know when two resistors are connected in series. What is important is, you know this voltage divider rule. In a series circuit, the current flowing through each element is same, and the voltage through every resistor will get divided. And if you add all the voltage drops, V1 plus V2 plus V3 will give you Vs again. You can write this formula for the different resistances and add them, and you will find out. That is fairly obvious. Okay. Now, second thing that we need to know is, what is a parallel connection? Okay, if this is a series connection, then what will be a parallel connection? Can you just guess based on what we have done or what you already know? A parallel connection is, a series connection is when the current through every element is same. A parallel connection is, we say that two elements are said to be connected in parallel if the voltage across each element is same. Okay, if voltage across each element is same. If voltage across each element is same, then we say that these two elements, 2, 3, 4 elements are said to be in parallel. Okay, if the voltage across them is same. Let me again draw an illustrative circuit for this. Let me just draw give you an example. Again, let's take a source voltage. Vs. This is plus, this is minus. And now let me take a few resistances. Let's say this is resistance R1 and this is resistance R2. Okay. Now, if you see, these two are said to be in parallel because the voltage across these two resistances is same. What do I mean by that? What I mean is, suppose you take a multimeter. Okay, you take a multimeter, you place a probe here, and you connect a voltmeter. What will be the reading? The reading will be Vs, right? Why? Because we know that this is Vs, so you have just connected a voltmeter across it. Now, take the same multimeter, and connect it across these two leads. This voltmeter will again give you Vs. Similarly, take another multimeter and connect it here. this will again give you Vs. This voltmeter reading will also be Vs. So basically, when two or more elements are said to be in parallel, if the voltage across each element is the same, then we say that these two elements or more than two elements are in parallel. Now, why is this important? Because in a parallel connection, the current gets divided. And if you want to find the current flowing through one branch, what do we mean by current getting divided? What I mean is, see, this circuit will produce a current I. This current will flow till this point, and at this point this current gets divided, right? This current should get divided into two separate branches. So let's say some current will flow through this resistance I1, and some other current will flow through the other resistance. Let's call that current I2. Now, how can you find I1 or I2? So current flowing through R1, that is I1 will be given by, just a minute, I1 is equal to, see, what was voltage divider rule? If you want voltage across one resistance, take that resistance divided by the sum of all the resistances. Here, if you want the current flowing through this branch, take the other resistance. Take R2 divided by the total resistance, R1 plus R2, multiplied by the total current. This is the current divider rule. This was the voltage divider rule. This was the current divider rule. This is very helpful. Okay, this is of course a special case for two resistances. If there are more than two resistances, the more general case for a current divider rule is current flowing through a particular resistance is given by 1 upon R1 divided by reciprocals of all resistances. Multiplied by the current. This is the general rule. This is a special case for two resistances only. Okay. So I hope so far everything is clear. What is a series connection? What is a parallel connection? There is one more important topic before we go on to the main topic. The main thing that we are going to do today is Kirchhoff's laws, KCL, KVL, and using KCL we do nodal analysis. But there is still one more topic. See, everything that I am explaining today is because I want to build some kind of an intuition for these circuits. Then you will find solving these circuits as fun and you will find it easy. Okay, one more thing that I would like to explain is what is a short circuit and what is an open circuit. Okay, what is a short circuit and what is an open circuit. Alright, let's see what is a short circuit first of all. Suppose you have a wire like this. Okay, this is one point A, this is another point B. If you connect these 2 points, in electronics terminology, we say that these 2 points have been shorted. They have been connected. So this particular connection is called as a short circuit. Now, as far as a normal copper wire is concerned, let's say you have some kind of a copper wire in your laboratory and you try and do this connection. A copper wire is a conductor, right? Even a good conductor will have some resistance. But when it comes to electronic circuits, one assumption is all conductors have zero resistance. So we are assuming that these are perfect sort of conductors and there is no resistance in the wires themselves. Of course, that's an idealization, but it works pretty well for as long as electronics is concerned. So the resistance between these 2 points is zero because you've connected a good conductor, like you've actually connected a copper wire between 2 points. You've connected a good conductor, right? So in this case, the resistance will become zero. This is important, okay? If 2 points are short circuited or they are shorted together, that means the resistance is zero. Now, if the resistance is zero, can you tell me what is the voltage? Voltage by Ohm's law is V is equal to IR. That means the voltage is also equal to zero. The resistance is zero. The voltage at both these points, whatever voltage you'll get here, okay, whatever voltage you'll get at this point, the same voltage you'll get here, VA will be equal to VB. That is the meaning of V is equal to zero. That means these 2 points are not at different potential. They are at same potential. VA and VB will be equal. What do we mean by this? VA will be equal to VB. So whenever there is a short circuit between 2 points, what you need to remember is the resistance between those 2 points is zero and the voltage across those 2 points is also zero. Both those points are equipotential. And what about the current? Now the current is interesting. The current in a short circuit is always unknown. you cannot comment on it directly. You have to find it out. The current will always be unknown. Okay, this is a short circuit. This was a short circuit. Now let us try and find out what is an open circuit. Okay, so this is important. This is for a short circuit. Let me just write it down. These conditions are for a short circuit. Now let us take the case of an open circuit. Again, I have a point A, I have a point B, and now nothing is in between them. That means I don't connect them, I keep them open. In this case, this particular circuit is called as an open circuit. This will be called as an open circuit. Now tell me, there is no conductor between point A and B. There is no element, there is nothing connected between A and B. So what should be the resistance? The resistance will be, in this case, infinite. The resistance will be infinite. Okay. If the resistance is infinite, can any current flow through here? See, here some current could flow, right? Some current could flow through this. Can any current flow through? No. So the important point for an open circuit is the current flowing through 2 points which are open circuited is 0. The current flowing is 0. These are very, very essential points when it comes to an open circuit. And what about the voltage then? In this case, the voltage is unknown. That means you cannot immediately comment. You can find it out. You can find it out by using some of the techniques that we learn, but the voltage will be unknown. You don't know. You cannot immediately comment on it. Okay. So in this case, VA will not be equal to VB. That is different. In this case, VA will not be equal to VB. That means there will be some potential difference between these 2 points. Alright. Now we are almost in a position to start KCL, KVL. However, there is one more point that I would still like to cover. Okay. There is one more point that I would still like to cover. And that point is basically just I want to give you some intuition about voltage. Okay. Some kind of an intuition about what exactly is voltage. Now, not basically about voltage. You know what is voltage. Basically what I want to do is, let me just write it down. So let's say you have some kind of a voltage source here. You have some kind of a cell. Okay. And this is plus, this is minus, and this is 10 volts. This is 10 volts. This is given in the, this is some part of a circuit. Now remember, this particular terminal, if you consider, if you again take a voltmeter, let's take a voltmeter over here. I place a voltmeter, one lead here and one lead here. Okay. I connect a voltmeter across. What will be the reading? The reading will obviously be 10 volts. Okay. That means this plate is 10 volts higher than this plate. The voltage at this plate is 10 volts higher than this plate. That means this particular plate is at 0 volts. This particular plate is at 0 volts. So this will be at 0 volts. If this point is at 0, see, if you see these 2 blue points, is there a short circuit between them? Yes, they are directly connected. That means this is also at 0. 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 That means when you see a symbol like this, a voltage source with 10 volts, this voltage is always measured with respect to ground. So this plate will be grounded even if they don't show you this grounded symbol. Okay. Always remember, what is another term for voltage? Potential difference. Whenever you say voltage, it is the potential difference between 2 points. So you need 2 points. So if they tell you voltage is 10 volts, where is the second point? The second point is obviously ground. So all these points are at 0 volt and all the points above will be at 10 volts. This is 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 at 10 volts. Okay. This is a very, very crucial thing. So every single voltage in the world will be measured with respect to ground unless stated otherwise. Unless the problem tells you that this point is at this potential, this point is at this potential, that is a different matter. Otherwise, let's take another example. Suppose you have something like this. Let's say you have a 20 volt voltage source. This is the symbol for a constant voltage source. This is the symbol for a cell or a battery. Okay. So let's say this is a 20 volt constant voltage source. A constant voltage source is basically, it will produce a constant voltage irrespective of what is going on around it. A constant current source will produce a constant current value. A constant voltage source produces a constant voltage value. That means all these points will be 20 volts. All these points will be 20 volts. This is plus 20. This is plus 20. This is plus 20. This is plus 20. This will be 20 volts. And all these points below will be connected to ground. Okay. This point, this point, this point, this point. All of these points are connected to ground. That means they are 0 volts. Okay, this intuition is important if we are to understand what comes next. Now we are finally in a position to start with what is perhaps the most well-known laws in electronics after Ohm's law, that is Kirchhoff's law, that is Kirchhoff's current law and Kirchhoff's voltage law. So let's look at Kirchhoff's current law first, and then we'll go on to Kirchhoff's voltage law. Okay, let's start with Kirchhoff's current law. Kirchhoff's current law first. This is very popularly abbreviated as KCL. That is the abbreviation I'll use as well. Okay, what is KCL? Basically, according to KCL, the algebraic sum of currents, the algebraic sum of currents across a given node, or junction, at a particular time t0, at time t is equal to t0, is equal to 0, What do we mean by that? Let me draw a diagram so that you understand. Okay, so let's take, this is one branch, this is another branch, this is the third branch, this is the fourth branch, this is the fifth branch. Okay, a node is where two or more elements, two or more connections are made. That is what a node or a junction is called. So let's take this as the node. Let's say one current is coming in, that is I1. Let me use a different color. Let's take, this is I1. This is I1. This is I2. This current I3 is entering. This current I4 is leaving. And we have one more current I5 which is leaving the node. Okay. What KCL tells you is, when you add all these currents, this will be 0. And what is the convention? The convention is, incoming currents are taken negative. Incoming means incoming into the node. Incoming currents will be negative, and outgoing currents will be positive. So यहाँ अगर आप KCL लगाओगे तो KCL से आपको क्या मिलेगा? Using KCL, what you will get is, in this case, minus I1, that is an incoming current, plus I2 outgoing, minus I3 plus I4 plus I5 is equal to 0. That will be your KCL. Okay. Now let's take a very simple problem based on KCL. Let's take a very simple problem, but this is a good conceptual problem. Let me draw the circuit first. This is a symbol of a constant current source. Okay, don't forget, I told you this is a symbol for a constant current source. A constant current source of 8 amperes, then a resistance of 4 ohms, another resistance of 2 ohms, another constant current source of 10 amperes, and all of these are connected together. All of these are connected together over here. Okay, and the question is, find the voltage through the 2 ohms resistance. Problem is, find the voltage through or across, not through, find the voltage across 2 ohm resistors. Across 2 ohms resistance. So basically you have to find the voltage across 2 ohms. This is the question. Now how do you solve it? Now first tell me, can you identify any node here? Can you identify any node? If you see, at this point there are more than 2 elements. 1 element, 2 element, 3 element. So this is a node. This is called a principal node, where there are only 2 elements joining or meeting. That is a simple node. 2 or more elements meeting together is called a principal node. So this point is a principal node. And wherever there is a principal node, current division will take place. Here there will be no current division because there is a simple node. Current has nowhere to flow, right? Current is like water. If water has only one path, it will flow along that path. Only when water has more than one path, then it takes both the paths. Current behaves something very similar. Now at this point, let's call this point A. Okay, I want to apply KCL. So what is the first current coming in? See, this 8 amperes is coming in, right? This 8 amperes is what is coming in. So this current, let's call this 8 amperes. We are not calling it, it's given, this is 8 amperes. This is 10 amperes, this is coming out. That means this current is also 10 amperes. This is 10 amperes, this is 8 amperes. Now I need to know whether the current from here is coming in or going out. Now I think in this problem it is fairly obvious. So I'll assume this, that the current is flowing in this way. Current is flowing in this way. This is current through the 2 ohm resistance. This is current through the 2 ohm resistance. Okay, this current, let's call this unknown current I. Now let us apply KCL at point A. KCL at point A will be given at incoming currents are negative. So minus 8 amperes plus I. Outgoing currents are positive, plus 10 amperes is equal to 0. So this will give me I is equal to 2 amperes. If my current turns out to be positive, that means my assumption was right. My assumption was current is coming this way. That is a correct assumption. So I got the current through 2 amperes. If this is the current, do you remember the convention that I told you? In the direction of current, this is plus, this is minus. This is plus, this is minus. So now can you tell me what is the voltage through 2 ohms? That is nothing but Ohm's law. I into R. Current is 2 amperes. Resistance is 2 ohms. So the voltage across 2 ohms resistance is 4 volts. That will be your final answer. This is one way we apply KCL to find out real values. Okay. Now let us move on to the other Kirchhoff's law, that is Kirchhoff's voltage law. Let's look at Kirchhoff's voltage law. Of course, you can pause the video later. This is a YouTube video. आप इसको बाद में pause करके लिख सकते हो. Okay. Let's try and study Kirchhoff's voltage law. What is Kirchhoff's voltage law? Okay. According to KVL, the algebraic sum of the voltages or the potential drops of the voltages, the algebraic sum of the voltages across a given loop, or a mesh, that is nothing but a closed path. A loop simply means a closed path. Along a loop or a mesh is equal to 0, at some time t is equal to t0, at time t is equal to t0. Okay, so the algebraic sum of the voltages across a given loop is equal to 0. Basically, if you want a one line summary of what we are saying is, you add all the voltage drops, all the potentials across a circuit in a closed loop. This will give you 0. You keep adding all the voltages, come back to one particular point, you should get the addition will be 0. Okay, now the important thing, and where many students get stuck in my experience, what I've seen is, how do you apply KVL? Applying KCL is very easy. Many students find KCL quite easy. Now the thing is, how do you apply KVL? How to apply KVL? Okay, the first point is either they will give you a current direction or you assume a current direction. या तो क्वेश्चन में आपको करंट डायरेक्शन दिया जाएगा या आप खुद एक करंट डायरेक्शन अज्यूम कर लो. ओके, assume a current direction. If not given, that means if they have given you a current direction, use it. If they have not given, you assume it. You are assuming it, so there should be no confusion. Assume any direction, finally you will see that your answer is right. If you assume clockwise, I assume current anti-clockwise, we still will get the same answer. That is the beauty of KVL. So there should be no confusion in your mind. You see a circuit, you want to apply KVL. If it is if the direction is not given, you assume a current direction. Okay, you assume a current direction. Now what does KVL tell you? It tells you go along a loop and add the voltages. Okay, go along a loop and add the voltages. If you have to go along a loop is a closed path, right? You can go clockwise or you can go counterclockwise. Again, students get confused. So you choose a direction. Choose a direction in which to travel. Choose a direction in which to travel along the loop. Okay, so again, this is up to you. You choose clockwise, you choose anti-clockwise, doesn't make a difference. You go in the direction of current, you go opposite to the direction of current, does not make a difference. You will get the right answer. So you be rest assured, this method will work every single time. Choose a direction in which to travel along the loop. Now what you should do, you've chosen a direction, move along the path, move along the path, simply move along the path and add the voltages, add the voltages, add the voltages till you reach the starting position, till you complete the loop, till you complete the loop. Basically, you start from a point, come back to the same point till you complete the loop, till you complete the loop. Okay, now I hope this is very clear. There should be no confusion on this. This is, see, one thing that I forgot to mention in the previous topic also. Algebraic sum of currents, algebraic sum of voltages. That means if you choose plus and I choose minus, see, finally the answer will be same. Why? Because after all, everything is equal to 0, right? So this is an algebraic sum. So which convention you use does not matter. You will still get the right answer. Even if we choose to, you choose opposite direction, I choose opposite direction, our answers will finally match. And we'll see that. We'll see that in a bit. Now, okay, this is a method. This is the this was the method that I gave you, and you're going you want to follow this. Okay, what do you, when I say add the voltages, how do you add these voltages? Will these voltages be given? So let me explain that as well. So there are only 4 cases that you need to remember, and these are not 4 cases like very complicated or something, very easy. So let's take, this was a voltage source V, another voltage source V, another voltage source V, one minute, I'll better draw this a little better so that there's no confusion on your end. Yeah, this is minus, this is plus, this is a voltage source again, and there is a resistance, there is a resistance. Again, 2 cases, one is current is flowing in this direction, same resistance, but the current is flowing in the opposite direction. Okay, now how do you apply KVL? I mean, you are applying KVL and you come across this. Now what do you do? So for this example, what we are going to do is, we are going to assume you are moving in this direction. Okay, you are moving in this direction. You will be moving in this direction throughout. This is your direction. This is your direction. Remember, I told you that you have to assume a direction. You are moving in this direction. Okay, when you are moving in this direction, which sign did you occupy, which sign did you encounter first? First you got a plus sign, right? Plus V. You were coming left to right, which sign do you see first? You strike the negative terminal, right? Minus V. You are coming in this direction, left to right, current is also flowing in the same direction. Your direction and current direction is same, write a plus sign. So this will be plus V. And what is plus V? Plus V will be by Ohm's law, IR, right? So you can write plus IR. Your direction, you are moving from left to right, current is moving in the opposite direction. In this case, you will write minus V, or you will write minus IR. Is that clear? Only two things are possible. You will either encounter a voltage source, or you will encounter a resistor. If a voltage source, either the polarity is positive or negative, whichever you hit first, write that sign. If for a resistor, current is flowing through the resistor, so voltage is V is equal to IR. Now the question is, should I take plus V? Should I take minus V? Your direction, current direction is same, plus V, plus IR. Your direction, current direction opposite, minus IR. That is all. You can solve any electronic circuits using this KVL. Okay, so remember, this is not what you learned in your 11th standard or HC Verma. HC Verma in 11th standard you learned potential drop, potential rise. Forget everything. It's just a convention. Use this convention and you will be fine. Okay, you don't have to remember, oh, your potential is rising, so take a minus sign. Your potential is going down, forget everything. You strike positive terminal, take plus sign. You strike negative terminal, take minus sign. इससे आप इलेक्ट्रॉनिक्स का कोई भी सर्किट सॉल्व कर सकते हो. ट्रांजिस्टर का कोई भी सर्किट आप कुछ सेकंड्स में सॉल्व कर, कुछ मिनट्स में सॉल्व कर पाओगे यूजिंग केवीएल. Okay, it will hardly take you 1 or 2 minutes. So don't forget this. This is very, very, very crucial. Now let's take an example so that you understand. Okay, let me take an example. Let's take a problem, very simple problem. Again, we'll start with simple problems. So you have a constant voltage source of 10 volts. This is given. This is a constant voltage source of 10 volts. Then you have a resistance of 2 ohms. You have another constant voltage source of 5 volts. Another resistance of 6 ohms. Another constant voltage source of 15 volts. Another resistance of 10 ohms. Another resistance of 10 ohms. Another voltage source of 20 volts. Another voltage source of 20 volts. Another resistance of 5 ohms. Don't worry, this looks scary, but this is not scary at all. Okay, so whenever I teach electronics, half of my time is spent in just assuring physics students that electronics is not that difficult. For some reason, physics students usually have some kind of a phobia of electronics. How do I know? I had that phobia too. So if I learned electronics, anyone can learn electronics. This is not a difficult subject at all. A very good subject, and in fact, a very scoring subject when it comes to IIT-JAM or CSIR-NET exams. So basically, this topic is important for both. Okay, this is not JAM level or NET level. This is important. This is the first topic we'll teach you in coaching for both these courses. Whether you come for IIT-JAM or NET, CSIR-NET, this is how electronics will be taught, because this is the heart of analog electronics, as I told you. The question is, find the current. Current is given. Find current I. Find I. That is the question. Very straightforward question. So now, how do you apply KVL? First, we have to assume current direction if not given. Your direction is already given, so you don't have to worry. Now you have to choose a direction. That was your second step. So I'm going to choose this direction. I'm going to go clockwise. I'm going to go clockwise, and I will come back. So I will start at this point. I will start at this point. Another convention we told you is, I told you at the beginning, is in the direction of current, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus. In this particular problem, we won't need this, but just to reinforce that convention. Now let's start. Okay, let's start. I start moving in this direction. I start moving in this direction. From this point, I come here. I see a resistance. Is my direction and current direction same? Yes, see, I am moving left to right. Current is also moving left to right. So plus IR, plus I into 2. Okay, plus I into 2. I'll write this as 2I plus 2I. Okay, then I keep moving. I get a 5 volt source. Which terminal I strike first? Positive terminal. So plus 5 volts. Okay, plus 5 volts. Next, I keep moving here. I keep moving here, and I see another resistance. My direction, current direction is same. So plus 6I. Plus 6I. I into R. I keep moving here. I keep moving here, and I see a positive terminal. So plus 15. Plus 15. Plus 15 volts. I keep moving here. My direction, current direction is again same. So plus 10I. I strike a positive terminal. Plus 20 volts. Again, my direction, current direction same. Plus 5I. I strike a minus terminal. Minus 10 is equal to 0. Later on, if you solve everything, you will get the current will be, I think, minus 30 by 23 amperes. Not I think, I solved it. So you'll get minus 30 by 23 amperes. This will be your current. So hopefully you understood how we have to apply this KVL. Okay. If you understand KVL, trust me, you have understood transistor circuits. There's nothing more to solving transistor circuits apart from KVL. Okay. You'll see in the next lectures how we can solve transistor circuits within a matter of minutes once you know how to apply KVL. Okay. Let's do one more problem. This is an important topic. So I'd like to do some more problems just so that you get a feel for this of how we are going to solve these problems. Let's take one more circuit. This is problem number 2. I have a constant voltage source of 10 volts. 10 volts. I have a resistance of 10 ohms. I have another resistance of 20 ohms. Then I have a current source, constant current source of 2 ampere. Constant current source of 2 ampere. Another constant voltage source, 40 volts. Sorry, I know my handwriting is not that good. Hopefully you are able to follow along. And a resistance of 5 ohms. Yeah, that's it. That is the circuit. Question is, find the voltage across this 2 ohm resistance. Find the voltage across 2 amperes. Sorry, not 2 ohms. Find the voltage across this 2 ampere source. Okay, find this. That is the question. Now the thing is, see, this is a voltage. This is a constant current source, right? I have to assume where the voltage might be. So I am assuming the voltage is like this. This is plus, this is minus. I don't know. I don't know. For a constant current source, the current value is known, voltage is unknown. For a constant voltage source, voltage value is known, current value is unknown. So here I am assuming this is the direction. This is an assumption. This is an assumption. Okay. Now let us try and apply KVL. First, let us see what is the current direction. Is the current given? Yes, it is quite clearly a series circuit. So this is the current, right? This is the current. This current is I. What is that current? Current is equal to 2 amperes. How do I know? This value is given here. This value is given. So this is 2 amperes. Now, see, this current flows through 20 ohms resistance. This current flows through the 20 ohms resistance. What will be the voltage generated here? Okay. In the direction of current, plus. This is plus, this is minus. This is plus, this is minus. Okay. What is this voltage? Do we know this voltage? Yes. Why? Voltage is IR, right? V is equal to IR. I know current. I know resistance. 20 twos are. This will be 40 volts. This is 10 twos are. This will be 20 volts. 5 twos are. This will be 10 volts. So I also got the voltages. Now let us apply KVL. Again, I have to choose a direction, right? I have to choose a direction. So again, I am going to choose the clockwise direction. I choose the clockwise direction. I start from this point. So applying KVL, first I get minus 20 volts, minus 20, minus 40. This voltage is voltage across 2 amperes. So minus voltage across 2 amperes plus 40, because I reach a plus sign, minus 10, minus 10, minus 10 is equal to 0, is equal to 0. Okay. Now, finally, when you solve all of this, this voltage across 2 amperes, is, wait, did I make a mistake? No, that's right. This 40 cancels out, minus 20. So this voltage turns out to be 40 volts. This voltage will turn out to be 40 volts. Is that clear? I hope you got this problem as well. How we solved it? Basically, I just want to give you an intuition of how we use KVL. Okay, this is how we use KVL in circuits. All right. One more problem. One more interesting problem. I hope this is clear. So you move with the here. I already use IR. That's why I am not using it here. I already found out the voltage because the current was known to me. Let's do one more interesting problem. Third problem. Again, a circuit is given. This is resistance R1. This is resistance R1. Value is not given. This is resistance R2. Again, value is not given. A constant voltage source of 12 volts. Another resistance is connected like this. This value is also not given. R3. There is another constant voltage source over here. Plus, minus. This is 24 volts. This is 24 volts. And one more constant voltage source. Plus, minus. This is 10 volts. This is 10 volts. This is the given circuit. And the question is, in the questions they have marked some voltages. This is V1. This is given in the question. Okay. This is V2. And this is V3. This was already marked in the question. V1, V2, V3. Oh, sorry. This was V2. Of course, it won't make a difference. Leave it. It won't make a difference. This is V1, this is V2, this is V3. Okay. Question says find V1, V2 and V3. Find V1, V2 and V3. That is the question. That is the question. Now let us try and apply KVL. See, we don't know the value of resistances. But the thing is, they haven't told us to find out current, right? They just want this voltage. So already voltage polarity they have marked. So we can just use it. So the important thing is to choose the loop wisely. We have to choose the loop very wisely. So what I'm going to do is, first I'm going to move in this direction. Why do I choose this loop? Because see, I have a closed loop and I have only one unknown quantity here. That's why I have chosen this loop. So let me write down the KVL for this loop. KVL for loop 1. KVL for loop 1. What will be KVL for loop 1? For loop 1, KVL will be, let's start from this point. Let's start from this point. Plus V1. I come here. I reach a plus sign. Plus 10 volts. I reach another plus sign. Plus 12 volts. Minus 24 is equal to 0. From this, if you solve, you will get V1 will be equal to 2 volts. You can solve this later and check that your V1 will be 2 volts. V1 will be 2 volts. Okay. Now I need to choose another loop. Because there are another two quantities that I have to find out. let us choose this loop now. 1 minute, I'll just erase this. Yeah, now let me choose this loop. Suppose I choose this loop. Now already V1 I already know V1, so only one unknown quantity again. So KVL for loop 2, KVL for loop 2, KVL for loop 2, KVL for loop 2 will be plus V1 plus V2 plus 12 minus 24 is equal to 0. I already know V1 is 2. From this, my V2 will be equal to 10 volts. V2 will be 10 volts. And similarly, now I need a third loop. And that third loop I'll choose as, let me choose this loop as this triangular loop. Okay, I'll choose this triangular loop and see what I get. So KVL for loop 3, this will give me plus V1, which is known, minus V3. See, I'm coming in this direction. So this is minus V3, minus 24 is equal to 0. V1 is already 2 volts that I know. So V3 will be minus 22 volts. V3 will be minus 22 volts. V3 is minus 22 volts. Now, what does this minus sign signify? This minus sign tells you that the polarity that they have given in the question is wrong. Actual polarity is opposite. So you don't have to worry about your assumptions. Now in this case, the examiner made an assumption for you, but still your answer was wrong. Answer was right. Why? The minus sign tells you, oh, the polarity that you have assumed is wrong. So this minus sign is very useful in electronics. This tells you that polarity is actually opposite. Okay. So this is how we use KCL and KVL and we solve different electronic circuits. Okay. Now, this was a very, very basic lecture, I know, based on KCL, KVL. But in the next lecture, which will be on transistors, you'll see how we use KVL, itself to solve all kinds of transistor circuits, Okay. So hope you learned something in this video. So thank you, and we'll end this video here.